Alright, so we're talking once again about concepts in 4.4. 4.4 talks about the natural log. And we talked about the natural log being the log base e. E is 2.71828. Not so important to memorize that, but because we can find it on the calculator by just simply using the e to the x power button on our calculator. So this is our natural exponential function here, natural log here, base of e. Log base e is natural log of x. So if we keep going, we talked about continuously compounded interest. That's one application of the base of e. If it's continuously compounded, we always use e to the, a of t equals p times e to the r-teeth power right down here, continuously compounded interest right there. If we're given just in general a growth factor of a population, for example, if a growth factor for a population is a, then instantaneous growth rate r equals ln of a, the natural log of a, because in general f of x equals c times a to the x power is the same, corresponds to f of x equals c times e to the r teeth power. Sorry, I should say x power if we're going to be consistent. To the x power. The c is the same. Here's our standard exponential form. Here's our instantaneously growing population, or instantaneous exponential function. C is the same, x is the same, and the only thing that's different now is the fact that a, our growth factor a, is equal to e to the rth power. So if a equals e to the rth power, what we can do is take the natural log of each side of that equation, take the natural log of the right side as well, e to the rth power, and if we have, just by following the rules of exponents, we can take that r down to the front on the left side. Ln of a stays the same. R becomes, instead of an exponent, becomes a coefficient of the right side, r times ln of e. Ln of e, well, if our base is e, e to what power is e? E to the first power, so this just becomes 1. Ln of a equals r, or r equals ln of a. So that's how we get r equals ln of a. If we're given a growth factor here of a, we can calculate what the instantaneous growth rate is by saying that r equals ln of a. So if the growth factor is 1.5 in a specific situation here, if the growth factor a for a population is 1.5, a equals 1.5, then what is the instantaneous growth rate? R equals ln of a. R equals instantaneous growth rate equals ln of 1.5, and r equals ln of 1.5 is 0.405, and that becomes our instantaneous growth rate, 0.405. And if we wanted to use this to make a exponential function describing that, that would be f of x equals c, some starting amount. We don't know what that is in this example, but c times e to the rx power, because we're using our variable x. F of x then would become c, whatever the starting amount was, times e to the 0.405 times x power. And that would be an exponential function describing the growth factor of 1.5, or the instantaneous growth rate of 0.405.